Alright guys, so today we are going to be learning about our last section with these quadratic functions. This is all about graphing absolute value functions. Now what is nice is these are honestly pretty similar to graphing vertex form that we just learned in our last class. It just looks a little bit different. So a few definitions that you need to know are an absolute value function. We have dealt with absolute values in the past, so at least seeing an absolute value function shouldn't seem too new, but the definition just states that it's a function that contains an absolute value expression. So remember that our absolute value expression would just look like this. So those two lines around some number. Translation is a transformation that shifts a graph horizontally or vertically, but does not change size, shape, or orientation. So we've dealt with transformations already in our vertex form where we had to move left or right, and in our standard form even where we had to move up and down. Vertex form also has us moving up and down. And then this last one that we kind of introduced, which we kind of covered again already, but it is called a parent function. So this is the most basic function in a family of functions. So leading up to this, we've done a lot of compare. So if we had x squared plus 5, and we were comparing that to x squared, that x squared would be considered our parent function because that's what we're comparing everything to. Okay, so looking into these absolute value functions, we have these kind of 4 different types of translations that we'll be looking at today, and they honestly follow the same kind of concepts that we've already covered with our other types of functions. So our first one, we have the absolute value of x plus k. So this means that we are going to go up whatever k is. If we have the absolute value of x minus k, that means that we are moving down. So remember, plus is up, minus is down. And then these last two, we have the absolute value of x plus h and the absolute value of x minus h. So these kind of go back into that vertex form that we just discussed, where anything inside the parentheses was opposite. So this tells us if we move left or right, but everything is opposite. So normally you would think if it was plus k, or I'm sorry, plus h, that we move to the right, but it's going to be opposite. So this means we move to the left. So then if we have x minus h, that means we move to the right. So inside your absolute value tells you if you move left or right. Outside tells you if you move up or down. And remember, inside is always opposite. All right, so let's get into graphing these translations. So for this first one, it says, what are the graphs of y equals the absolute value of x and y equals the absolute value of x minus 2? So what we're going to have to do is set up 2 charts. So we're going to have the chart for the absolute value of x, and we're going to have a chart for the absolute value of x minus 2. Remember, for our charts, the best options to use for your numbers are -2, -1, 0, 1, and 2. And then we just start plugging in our numbers. So if we plug in -2 for x, for the absolute value of x, well, the absolute value of -2 is 2. The absolute value of -1 is 1, absolute value of 0 is 0, and absolute value of 1 is 1, absolute value of 2 is 2. So now we do the same thing with our other equation, except it's a little bit different. So we have to do the absolute value of negative 2 minus 2. Well, the absolute value of negative 2 is just 2, and then 2 minus 2 is 0. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. Absolute value of 0 is 0. And 0 minus 2 is negative 2. Absolute value of 1 is 1. 1 minus 2 is negative 1. And absolute value of 2 is 2. 2 minus 2 is 0. Okay, so now we are going to graph these two equations. So I'm going to make this one in red. So negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Now with this type of graph, it is going to form a V. Those look awful. So absolute value graphs form a V. So in all the ones that we've dealt with so far, we have had a curve, we've had the parabola concept, but whenever you have that absolute value, your graph is going to be a V. And then we need to graph this one. I'm going to do it in blue just so you can kind of see what the difference is here. So we have negative 2, 0, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, 0. All right, so this shows you the two graphs. Remember that this red graph is considered our parent function. That is what we are always comparing everything to, is just the absolute value of x. So now, I know this problem doesn't ask us this, but if we were to compare our blue graph to our red graph, we would see that we shifted down 2, right? Everything went down 2 points. Well, that makes sense because looking here, absolute value of x minus k means that we move down. And if we look at that equation, the absolute value of x minus 2, that means that we should move down 2. So that just kind of puts it all together so that you can see it, compare it, see the parent function, and how our new function looks similar but different to that. All right, moving on. So this next one says, what is the graph of y equals the absolute value of x plus 3? Find the domain and range. So again, we make our xy table. Negative 2, negative 1, 0, 1, and 2. When we plug in negative 2 for x, the absolute value of negative 2 is just 2, and 2 plus 3 is 5. Absolute value of negative 1 is just 1. 1 plus 3 is 4. And the absolute value of 0 is just 0. Plus 3 is 3. And then this is where we kind of have our turning point. So again, absolute value of 1 is just 1. 1 plus 3 is 4. Absolute value of 2 is 2. 2 plus 3 is 5. So we are able to plot these points. Negative 2, 5. Oops. Negative 1, 4. 0, 3. 1, 4, and 2, 5. And we connect those dots to form this V. And again, this makes sense, right? Because our original function, the parent function, would have started at 0, 0. And with this function, we had that plus 3, so that means that everything had to move up 3 points, so our vertex moved up 3. And then it asks us to find our domain and our range. Remember, our domain every single time for these functions is all real numbers. Some of you like to put negative infinity to positive infinity, and that's also fine. And then our range always comes from our vertex. So here's our vertex, or here's our vertex, and you are looking at your y value. So you're going to have y, leave a little space, and then 3, because our y value at our vertex is 3. Now, looking at our graph, we open up, so that means that our range is greater than 3. So if we open up, it's greater than. If we open down, it's less than. Okay, on to our next one. So for this next one, it says, what is the graph of y equals the absolute value of x plus 5? Find the domain and range. So this one we have to do a little bit different, and you actually could have done this the same way with the past 2 problems that we've done as well. But instead of just using those standard numbers of -2, -1, 0, 1, and 2, you want to be able to find your vertex. So this is where you kind of have to look at our standard form, our parent function of the absolute value of x. So the absolute value of x, our vertex was at 0, 0, right? Well, now this new function that we need to graph is the absolute value of x plus 5. So what does that mean that we do with our vertex? How is it changing? What does this function do for us? Well, this plus 5 is inside the parentheses, or inside the absolute value. So that means we're either moving left or right. And since it's inside, that means that we are doing the opposite. So plus 5 means that we are going left 5. So that means that we go from 0, 0 as our original vertex, and then now we moved left 5 to create our new vertex. So when we make our XY table, our vertex is at -5, 0. And remember, if we know our vertex, we put that in the middle of our chart, and then we put 2 numbers above and 2 numbers below. Remember, it's always really nice to know our vertex, because then when we start filling in these numbers, we know that they have to just reflect each other. So when we plug in -4, we would have the absolute value of -4 plus 5. And that's going to give us the absolute value of 1, which is just 1. Well, that means that -6, whenever we plug that in, it also has to be 1. I'm going to make these look more like 1s because of this absolute value concept. I don't want us to get confused. And then when we plug in the absolute value of -3 plus 5, we get the absolute value of -2, which just gives us +2. And then whenever we plug -7 in, we would get +2 there as well. So now we can plot these points. And connect them into our V. The domain, always all real numbers. And our range, again, you want to pay attention to your vertex. So it is y, and then our y value at our vertex is 0. If we look at our graph, notice that we open up, so that means we will have greater than or equal to. So y is greater than or equal to 0. All right, and the next one, so kind of the same concept. We need to find our vertex first. So remember, in our parent function, this is our vertex. This is where we start. This also is our starting point for the x squared. That's our vertex for there. So your starting point for your parent function in the things that we've learned about is always 0, 0. It's always where you're starting. So in our new function, we have the absolute value of x minus 4. So that minus 4, since it's inside, it's going to tell us if we move left or right. And since it is minus 4, we do the opposite. So minus 4, we think we would move left, but since it's opposite on the inside, we will actually move to the right. So this is our vertex for our new function. So that is at the point 4, 0. So we just go ahead and put that in the middle of our chart. 2 numbers above and 2 numbers below. And now we just plug these numbers in. So if we plug 3 into our function, we have the absolute value of 3 minus 4. 3 minus 4 is -1, but then you do the absolute value, so it is +1. And then 2 minus 4 is -2, but the absolute value of -2 is +2. And then we know that 5 and 6 will just have to reflect over our vertex, so 5 should give us 1, and 6 should give us 2. So now we plot those points. I'm going to make this line go out a little bit further. And there's our graph. So then we state our domain and our range. You guys were doing really great with this on the quiz, where I think everybody put all real numbers for the domain, so you guys got that part. And then the range, again, we go back to our vertex. So we have y and 0. Our graph opens up, so it's going to be greater than or equal to. Now I know all of our problems so far have been that our graph opens up. That isn't always the case. But in a large chunk of cases, that is what happens, because with absolute values, our answers are always positive. However, in our last example, notice that it's a little bit more. So now we have numbers on the outside. So that's where you could have the possibility of your graph opening down instead. And so then your range would change to a less than concept if it opened down. So it says, what is the graph of y equals 2 times the absolute value of x minus 4 plus 3? Okay, so first thing we want to find out is our vertex. That's where we need to start. So again, remember, parent function vertex started here. Okay, so now notice that this guy and this guy are going to tell us how we shift to find our vertex. Or also remember, from our vertex form, those two numbers just give us our new vertex. So remember, from vertex form, this was our x and this was our y for our vertex. But remember, the x was always positive. So our vertex would be 4, 3. Or you can always just look at it kind of like we did the last couple problems. And we know that that minus 4 tells us if we move left or right. So that's going to tell us we go to the right 4. So went to the right 4. And then this plus 3 tells us that we have to go up 3. So this is where those translations kind of tell us to go. But if you notice, that new point that we just created is this same vertex here. So the absolute values in vertex form are very similar. The only difference is, of course, the absolute value symbols. So you just have to be cautious with those. All right, so now we can make our chart. We have our vertex at 4, 3. We put those 2 numbers above, 2 numbers below. And now this one is a little more tedious, so I'm going to go ahead and actually write it out so you can see kind of where all these steps are coming from. So we have to plug in 3 for x. So we have 3 minus 4, which gives us -1. Well, the absolute value of -1 is just 1. So now we have 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. Remember, this guy here is our reflecting point, so that means that 5 is also going to give us 5. And then we plug in 2. 2 minus 4 is -2. Well, the absolute value of -2 is +2. Then 2 times 2 is 4, and 4 plus 3 is 7. Again, our reflecting point then tells us that 6 would also give us 7. And our last step, 1, 2, 3, 4, 5, 6, 7. We plot these 2 points. 1, 2, 3, 4, 5. All right. And finally, we can state our domain, all real numbers, and our range, y, we open up, so it'll be greater than or equal to, and our vertex, the y value was 3, so our range would be at 3. So y is greater than or equal to 3. And then I just wanted to touch really quick on the compare concepts. I feel like you guys are doing really well on the left, right, up, down. Really the up, down, you guys have that. That's perfectly fine. You understand it. The left, right, if you can't graph it and you just have to base it off of the equation, is a little bit of a struggle still. So just remember, inside that parentheses, if it's positive, you go to the left. If it's negative, you go to the right. So that's why I kept saying it's opposite of what you might think it should be. And then the shrinking, stretching concept was really getting some of you guys on just trying to understand what's what. So something that just kind of like light bulbed on me the other day was if you have a whole number out front, whether it's positive or negative, it is going to be a stretch. So a positive or a whole number, whether positive or negative, will stretch. So stretching means that it's getting skinnier. If it is a fraction, no matter if it's positive or negative, it is going to shrink. And so remember, shrinking means that your graph is actually getting wider. So I feel like that might help some of you, because I feel like that was a really big struggle, was just trying to understand that concept of stretching or shrinking. So whole number is stretching and a fraction is shrinking. So hopefully that helps out a little bit. All right, but that wraps up all of our notes for chapter 8.